So the final part of this Unit 2 is going to be kind of putting a little bit of what you learned into practice. And I've prepared kind of a practical project for you to work on here. And we can also continue this into your own home, and you can look at a couple of different pieces of equipment in your own house as well. This piece of equipment is a shear. This is something a welding shop would use to actually cut large pieces of metal. And up here at the top you'll see there's a pretty substantial AC motor. And this is a pretty common project for us as electricians. We have to come in and analyze the information we've got. We've got this motor. We've got to get a branch circuit run over to this shear. And so we've got to look at the nameplate of the motor and make some determinations. So after looking at the nameplate on this motor, you can see that we have a voltage rating of 480 volts. We've got a current rating of 27 amps because this is a 20 horsepower motor. I've made that determination for you of the current draw. So my question is what is the power? How much wattage are we going to dissipate by powering this motor? Here's a second example. This is a welding unit, and this welding unit has a rating of 4,000 watts. And we're going to use 480 volts as a source of potential for this welder. So I am interested in knowing what the current value is going to be. So solve for current for this welder with 4,000 watts and 480 volts. This is a pretty typical example you'd see out on the job site also. Sometimes the carpenters might be working on the job along with us, and they'll have a table saw there, or maybe you've got a friend, or maybe even your own table saw in your own workshop. And we can begin to see that current and voltage are in a relationship with one another. And it's important to understand when we have a low voltage, oftentimes our current is going to be higher than if we had a high voltage. So in this case, I'm interested in knowing what the current value is going to be. So what is, solve for the letter I when you have a 230 volt circuit, and you know that you have 16 amps with a 115 volt circuit. Again, in continuing with our discussion about that relationship between voltage and current, a second table saw here. This one's set up as a three-phase circuit, so we got a couple of different voltages to select from again. So we have the option of 480 volts, or we have the option of 208 volt. And with the 480, notice my current draw is 2.1. With the 208, my current draw is 4.6. So here's the question: if you were a piece of wire, which load would you rather carry, the 2.1 or the 4.6? This is the last example I'm giving you on this project, and it's a pretty common problem. It's fluorescent lighting in a commercial building, and I've got a picture here of a ceiling, drop ceiling, and it's got 12 fixtures installed in the ceiling. And each fixture has 3 lamps, and each lamp is 34 watts per lamp. So, a couple of questions for you to answer. Number one, what is the current of all 12 of those fixtures if I'm using, say, a residential voltage of 120 volts? And then the second one is, what is the current value if I'm using 277. Now 277 is a pretty common voltage source that you'd see in a commercial application such as a school or an office building. So not something you're going to see right out of the starting gate as an electrician, but could come down the road. And again, it ties into what we're looking at, and that's that relation between voltage and current. So solve those two and compare those two numbers to each other, and let me know what you think.